Hey guys, so I just wanted to do the first problem with you on the practice redox reactions for the half reactions. So let's get started. So number one, assign oxidation numbers to each species in the reaction. So we know zinc is by itself, and all elements by themselves are neutral. There's no charge on it. So let me just get my pen. So it is 0. Hydrochloric acid is also neutral. However, hydrogen and chlorine are bonded, so they will have oxidation states now. If we look at our periodic table, we will see we have H and Cl bonded, so I'm just going to write that. So we have H bonded to Cl. Now, chlorine can have a whole bunch of oxidation states, and hydrogen can be different oxidation states as well. So how we're going to figure this out is first figure out who's going to be the negative one and who is going to be the positive one. So if we go down and check our electronegativity, chlorine is right here. Chlorine has a value of 3.2, and hydrogen has a value of 2.2 up here. So chlorine is more electronegative, so it will be the negative one of the two. Oh shoot. So, if chlorine is the negative one, that means hydrogen has to have the positive oxidation state of +1. Let's go ahead and make that a little cleaner. So if hydrogen has the +1 oxidation state, in order for this compound to be neutral as it is, chlorine must take on its -1 oxidation state. So going back to our document, we have hydrogen is +1 and chlorine is -1. For our next compound, zinc chloride, let's see. We have zinc chloride, and zinc is right here. It likes to be +2, and chlorine again can be a whole bunch of different oxidation states. Again, we're going to check electronegativity-wise who likes to be the negative guy. And we have, I already know off the bat that chlorine will be negative because chlorine is the nonmetal, and nonmetals have a higher electronegativity value. But you can always check this table. So chlorine is 3.2, and zinc is down here. Zinc is 1.7. So we know chlorine is going to be negative and zinc is going to be positive. And going back up, zinc really likes to be +2. That's its favorite oxidation state. And while you can't be certain that it won't be another oxidation state, it works out having each chlorine be -1, which is chlorine's favorite oxidation state. So it would make most sense if zinc is +2 and each chlorine is -1, and overall it's neutral, so it equals 0. So while I can't be 100% certain that this is the case, because both of them could be other oxidation states, this is the one that makes the most sense. So this is probably their oxidation states. So we have zinc is +2, and each chlorine is -1. Again, there's 2 of them. Lastly, we have H2, and any element not bonded to anything or bonded to itself is neutral. So H2 is neutral, so each hydrogen is 0. Yeah, so those are all of our oxidation numbers for all the different species. By species, I just mean the different elements or compounds in the reaction. So, which reactant was oxidized? So again, oxidation, Leo, lose electrons, oxidized. The only guy that is getting more positive from reactants to products is zinc. So zinc, and zinc starts off as a solid. I know it's not written there, but I just know that. So that is being oxidized. Which species was reduced? So which one is going down in oxidation number? And that would be hydrogen. It goes from +1 to 0. Now because HCl, because they're bonded together, this is really an ion. So we're going to write H +1 + 1. And that is our aqueous ion. Write the balanced oxidation and reduction half reactions. Okay, so we know zinc starting off as a solid, that's neutral. I know that solid isn't written there, but in most problems it will be written there for you. I'm just telling you now it's a solid. I would not expect that you would know that it was a solid off the bat. So that's in our reactants, and then in our product side we have zinc that's taking on the +2 oxidation state, and it's now in aqueous form. Also wouldn't expect you to know that without there being aqueous written up here. Okay, now we have to figure out where we write electrons. And you could have just memorized that oxidation means losing electrons, and losing electrons you write on the product side. Or you could just see that on the product side you have +2. So the only way to balance it out is to have 2 negative electrons, which gets you 0. Okay, so now we're looking at the reduction side of the reaction. We know that hydrogen is the thing being reduced because it's going from +1 to 0. So it is going down in oxidation number. So we start off with, on the reactant side, we have H +1 because it is bonded to something else. It's an ion. And that's on the reactants. On the product side, we have hydrogen that is neutral. Now, the reason why I'm not writing a little 2 subscript is because for balancing purposes, you have 1 hydrogen here, so you're only going to write 1 hydrogen in the product. And so ultimately, having 1 hydrogen, you're completely ignoring the 2 that's in front of it, in front of the HCl. So you have 1 hydrogen of +1 going to 1 hydrogen that's neutral. So this is being reduced. And so in order for that to happen, hydrogen is gaining an electron. And so of course, if oxidation and you're losing an electron and you have the electron written on the product side, for the reduction side, you're always going to have the electron written on the reactant side. The other way you could remember it is reduction starts with an R and reactants start with an R, so that's why the electron is written on the reactant side. And then you could double check charges. You have H plus and 1 negative electron, and that together goes to form 0. So charge-wise it works out as well. But the problem is that you can't just add these 2 half reactions together because you have different numbers of electrons being transferred. So you're going to have to multiply the reduction half of the reaction by 2 so that you can have the same number of electrons that are being lost as by what is being gained or added. So this 2 again multiplies onto this guy, and that guy. So I just went ahead and cleaned things up a little bit and distributed the 2 that was in front onto all of the different parts in the reduction half reaction. Now you can add the 2 half reactions and you'll see the 2 electrons on this side, cancel the 2 electrons there, and you are going to form an overall reaction, which the question doesn't ask, but I'm going to write it for you anyway. That looks like Zn, is there any Zn0 plus, you have 2H, and remember H, there is a spectator ion in this reaction, chlorine. Chlorine is a spectator ion because its oxidation number is not changing. So we're just going to throw it back in there. So we have the reactant side, Zn0 plus 2H, and each hydrogen is bonded to 1 chlorine. And then the product side, you have your ZnCl2. I know there are 2 chlorines, in part because it's written up top, but also because each chlorine has a -1 oxidation state, and zinc has +2, so you're going to need 2 chlorines to balance out the zinc. And then lastly, we have 2 H's, which is better expressed as H subscript 2, because hydrogen is a Brinkelhoff twinsy, so it's going to be bonded to itself. Okay, last 2 questions. Determine which species reactant is the oxidizing agent. So, again, the agent guy is like the confusing thing. It's always the oxidizing agent is the thing that's being reduced. So, that is our H plus 1. And the reducing agent is the thing that's being oxidized. So that is our zinc. If you're not sure about what the agent term means, go back to my level 2 video 1A, where I talk more about it.